Dr. Eugene Mallove, my guest. Gene, before we get into some of the other two different kinds of energies and possibilities, why can't we do cold fusion, though, in a mass-produced way? I mean, what's holding us back from doing it? Is it money? Is the technology just not there yet?
It's a little bit of both. Cold fusion actually probably partakes a little of the other kinds of energy. In other words, there's a unified physics, let's face it. The basic problem that we're facing is that our primary physics model of quantum mechanics, relativity, and many other things has some fundamental flaws. That's at root what's going on. The theorists, the mainstream theorists within cold fusion, have a certain idea that when you load up a metal lattice like palladium or titanium or something like that, you can get certain types of quantum mechanical coherence phenomena that produces this reaction. And they're driving, to some extent, the mental paradigm of this. But in actuality, the experimental techniques in cold fusion are all what we would call empirical. In other words, no one really understands at all, okay, in the cold fusion mainstream per se. They do not understand at all how it is working at a fundamental level. Now, in general, I would agree that you don't need to know for sure how something is working in order to make it commercial, providing that the nature of the reaction is powerful enough so that it goes. Like, for example, you don't need to understand fire to use fire.
Right.
All right?
You're right.
You just strike the match and it works.
Yep.
Okay, fine. Okay, everyone realizes.
And you depend on it.
Right, and you don't even know you don't need to know how radio works or TV works in order to enjoy radio and TV.
That is true.
Now, if someone over the last 15 years had been able to create a very practical device that could sit on your desk, or even one that you could sell to as a demonstration kit, as it were, to physicists, doubters, and so forth, we would have won the war already. But we have not been able to do that. It's very sporadic. Now, there are some scientists, I'll quote one in particular, I'll cite one in particular, one of the best, and we've given him $10,000 recently, which of course is nothing, but it helps him keep alive.
What do they do with that? They live off it, or they buy it?
Dr. Mitchell Schwartz, for example, in Massachusetts, not far from where we are, is an MIT graduate. He, at the 10th International Conference, had a device working around the clock that was producing several times the input energy consistently. And he can do that consistently.
Yeah.
He's one person who can do it consistently. But let me tell you, many of the other people in cold fusion, for example, are ignoring his work. So, one guy in the field, laboriously after many years, comes up with a way of doing it fairly consistently, and then he gets ignored by everybody else. But, for example, he probably, among them all, has probably the best shot. So what could be done, for example, with Dr. Schwartz, is that, let us say he received some further generous donations from us, or perhaps some investor would work with him to help him, because he's like a one-man or two-man shop, basically.
Right.
Get him going and get these, let's call them demonstration kits out there, which could go into high schools and colleges and so forth, so they could see a more robust version. There are high school students. We funded also Professor John Dash of Portland State University in Oregon. He had many students, high school students, interns, work on this, and they're continuing to work on it. They came to the 10th International Conference, and they have a little demonstration, not as powerful as Dr. Schwartz's, but it shows excess heat for sure. And, any high school student could do this. But that still leaves the question of where do we go from there? Yes, that might trigger further widespread belief in it, whereas now there's no belief, no acceptance by the dogmatic colleges and high schools that have just absorbed this garbage from the U.S. Department.
So there are no emerging public companies? I mean,
Yes, there is one. One is called Blacklight Power Corporation.
Okay.
Now, they do not like at all the word cold fusion. In fact, they claim not to be doing cold fusion, and I don't believe they are doing cold fusion. They have, under the auspices of Dr. Randall Mills, a brilliant man with some MIT training in electrical engineering, but an MD from Harvard University. 1991, 2 years into the cold fusion controversy, he came out with the general idea that the explanation that the cold fusion people were giving to the phenomena was not on target. He believes that the structure of the hydrogen atom is different, and he's assembled a team of PhD scientists in Cranbury, New Jersey, at the Blacklight Power Corporation. They have excess energy in plasmas, gas, high-temperature gas, that are using hydrogen and using noble gases like helium as catalysts, and are producing some rather spectacular results. They, however, have not got their energy density up. They're more reliable than cold fusion per se, in my opinion. They do it every single time. They have industrial partners. They have laboratories around the world that have replicated their work. And quite frankly, that is an avenue for at least a commercial investment perspective. That is one that people should look into.
But
it's a privately held company.
But it's not public then,
no, not yet.
And venture capitalists aren't throwing money at emerging companies.
No, you know where the venture capitalists are throwing their money? Well, of course, on damned hydrogen fuel cells. Now, what are hydrogen fuel cells? Hydrogen fuel cells are advanced technology that we've used to go to the moon. You know, we've used them in spacecraft, electrical power generation. You take oxygen with you take hydrogen with you, and you combine them together through membranes, and you get electricity, and you get water as a byproduct. Wonderful. But somebody has to make the hydrogen. And there's no such thing on Earth as a hydrogen mine, really, not a prominent hydrogen mine. We have hydrogen in water, and you need more energy to break that water into oxygen and hydrogen than you will get back when you recombine them in a fuel cell. So the people who are investing in fuel cells, indeed, it's a good technology, and they'll probably do very well.
And clean, right?
And it's clean where you burn it.
Where
you use the fuel cell. So indeed, if we had a magic wand, could convert every car to fuel cells overnight, we could, and had hydrogen supplies for them, okay, provided, of course, in conventional use by other energy sources, we indeed could clean up the air in Los Angeles and Mexico City.
But you might need fossil fuels to make it, right?
Correct. Or we would use fossil fuels. Some of the fuel cell people say, well, we just take the hydrogen off the hydrocarbon molecules. Well, now here's the problem. Why are these companies totally ignoring this other process?